Hey, it's Vinaya, and this is video 2 of me explaining a little bit about my 911 dispatch bot project. This video is going to be dedicated to explaining all the code and the different components that I built out in order to make this project a reality. I think I'm going to start off by just giving a general overview of the project and how it works. When a call originally comes into the system, Twilio is going to take it and reroute it to our local server. Over here, we're going to extract the key details and information provided and generate a new response, a new prompt to ask the user. The prompt is going to be sent to Twilio to be spoken to the user, and the current transcript is going to be sent to the front end in order to be displayed to the dispatcher along with the key information. And this is the main process that's just going to be repeated on and on until enough questions have been asked and until enough information has been provided to the caller in assisting them. This is a absolutely insane build. It has a lot going on, and it's definitely a much more advanced project, but I will be sure to explain all the code bit by bit, piece by piece, line by line in order to make sure that you understand all the different components and what's going on. So whether you're interested in web development, full stack, ML, GPT, whatever it is, I really do believe that anyone who's watching this video will be able to have some major takeaways. In terms of the actual tech stack that I've used, there is a lot going on. I was working with React, Twilio, Hugging Face, Open.AI, Google Cloud, NGROK, and probably a couple more that I'm forgetting. But this is an absolutely insane build, and I'm excited to share it all with you. Before we get into the build, I just wanted to mention, make sure that everyone's watched my first video in order to have a general understanding of the application that we're building out. And I also wanted to mention that if anyone's interested in running this application on their own local servers, you can head to my GitHub, and over here you'll be able to git clone the repository and you'll be able to run the application for yourselves. The only thing you'll need to change is the env file, which is where you store all your keys and your tokens that allow you to utilize different APIs and different services. So in our case, we're using Open.AI, Twilio, Google Cloud, Hugging Face. So you'll want to have your env file there in order to actually make API requests to these services. It's very important that you keep your env file to yourself. Don't share it to anyone. Don't share your keys with anyone, because these, as the name suggests, are your keys. They're kind of like your passwords, and they're what allow you to make these API requests. And if anyone else gets a hold of it, they might overuse them. They'll make you run out of your request limits, and it can even charge you if you have any money stored in your accounts. That's why I have an env sample over here, and that's why my own env file isn't pushed to my Git repository. I'll show you in this video how you can get your API keys for all the services that we use. So that shouldn't be too hard, but I'll also show my env file right now so that you can see format your keys and tokens are supposed to be in, just in case that causes you any errors later on. The only reason why I'm showing you my tokens is because I'm going to rotate my keys once I'm done recording this, because of course I don't want anyone using my keys either, but make sure once again you don't share them with anyone else. And yeah, with all that, I think that we're good to go and look at the application once more. So in my first video, I show you guys kind of general overview of actually making the calls to our application and getting everything working there. But I also want to show you a couple more features that we have in this application that I didn't have the chance to earlier. So some of those features include just being able to open up your emergencies, see all the key features that have been extracted. You can click on this button to call back the caller. You can see the transcripts here, and you can get the locations as well. And then from here, the actual dispatch officers will be able to begin scheduling the dispatch. It's very simple when the incoming calls being handled by the chatbot enter the system to assign it a priority level just by clicking here and kind of assigning it to one. So we assigned that one to 4, and it's now over here, and you can open up all the other ones as well. Aside from that, you can also toggle to the live and automated calls. So the live calls are the ones that are handled by the real life dispatchers, because of course some dispatchers will be available to handle the calls live, whereas the automated ones are all the ones currently being handled by the AI. And then we've got a bunch of other stuff going on the sides, but that's not really important. It's this that is the main bulk of the application. And with that, I think we can actually begin looking at the code. So the entire application is built out using React. So I just used the Create React App shortcut in order to get the entire application started up at the beginning. And that basically allowed me to get all these folders nicely organized and everything up and running. In React, the root file is within the source folder, it's this index.js file, and this is what allows us to call our entire application. From here in our app is where we're rendering both of our main components. This is our side and the main component. So the sidebar is this left sidebar that you can see, and then this main component is all this main middle stuff. The way that React works is it's a parent-child relationship, and you call different components inside one another in order to display it to the screen. This makes your code really reproducible, and you can reuse it really easily. You can send props and stuff, and we'll see that in a little bit as well. As for the styling, I'm not using plain CSS. I'm actually using a CSS framework called Tailwind CSS, and I can open that up over here. I'm not going to go through and explain all of the classes that I use with Tailwind. You can go here on the Tailwind CSS documentation and search them up if you are interested in learning about them, but this isn't a front-end tutorial, so I'm not going to go through that too much. So as I mentioned earlier, the main bulk of the content is that middle section, and that comes from this main component. So we're just going to go straight and look into that. It's over here in our sections folder, and we can open it up. Now, our main component itself is calling 3 more components: the header, the mid-header, and the content. And that's breaking up over here into the header, the mid-header, and then the content. And it's really important that when you're building with React to break up all your code into these different files, into these different components, because it ensures that, number one, your code's a lot more cleaner, it's a lot more easier to read it, and it's also a lot more easily reproducible. And again, this header and this mid-header stuff is just HTML stuff and CSS, so we're not going to worry about that too much. This is going to be what we're going to care about, which is this content component, which is over here. I'll explain a little bit why we have content 1 and content 2, and same with priority card 1 and priority card 2 in a little bit. It's just a little bit of a difference that I had in the features that I implemented. As for this content file, it's got a couple things going on. So we're just starting with the imports, and then we're just defining a couple of our variables. We've got an update label function that I will show you in a little bit what its main functionality is, and then we're actually displaying the content to the screen. As you guys can already see on our front end, there's 2 main parts. There's this automated and live attended toggle switch, which is being handled over here. And what this is basically saying is when you click on either automated or live attended, change the set automated value to true or false once you click on it, and then accordingly it changes this automated variable's value to true or false, and then accordingly it's changing the style. And then this automated variable is also impacting which information is being displayed on the screen. So either it's displaying priority cards with the priority card value being set to priority card, or otherwise when automated is set to false, it's being set to the data. And data and priority card store different lists of data, which I'll show you what that means in a little second. And what this is doing is saying if automated is true, so this is a ternary operator, if automated is true, display this, otherwise display this. And this is, once again, as I mentioned earlier, React is really good at reusability and reusing your code, and that's why we're able to display priority cards with different data accordingly without having to ever rewrite the code. And that's how we just switch between live and automated and live, and it's the exact same stuff with different data. So I told you I'd show you the difference between priority card and data, and we're getting these values up here from the data file, so I'll go ahead and show you exactly that. If we're using the live data, we just have this list of objects. And otherwise, if we're using automated data, again, we have these lists of objects, but they just have different information for now. Now, coming back to the content file, over here, the main thing we're doing is displaying this priority card file. And that's where all of our code handling the backend, the front end, actually getting the information from the AI, displaying the transcripts, everything is happening in there. But before I show you how this code works, I actually want to introduce you to the backend and the actual services that we're using. So we can go to the backend over here, which is all written in this index.js file. Whereas all of this is written in JavaScript and the React framework, this index.js file is a Node.js file, which is handling all of our backend. And by the backend, it's handling all of the code that is connecting to Twilio, and it's handling all of the code required to communicate with Open.AI and GPT, specifically the text Davinci 2 model. In order to actually run our entire application, we have to do a couple different things. We're running a backend and a frontend, which is commonly referred to as a client and a server. So in order to run our client, we run npm start, which sets up our React client, and then it will begin reloading our page in a second. And then over here, in order to run our backend, because we're using Node, we just wrote Node and then our file name, so index.jx. So it's reloading our front end. And I think I'll get us started off with Twilio, because that's the first step. When a call comes into our application, we want Twilio to accept the call and then reroute it to our own local server. And in order to do so, we start off by creating a Twilio account. If we come up over here, this is Twilio. And to get started, you just simply have to create an account. I've already created one. If you're interested, go ahead and create an account as well. It's very simple to get started, and then you can redeem a phone number, which is kind of like your application's phone number now. I already redeemed mine, but all you have to do is click on phone numbers, manage, and then active numbers, and you'll be able to easily get started there. Once you have a phone number, you'll be able to see both the friendly name and the phone number name. It's the exact same thing, just when you're calling the application, you'll want to call this number. And then what Twilio does is you have to tell Twilio what endpoint you want it to kind of get its functionality from when the number is called. And so you route it to your application. The only issue is that when you're using Node.js and you have your own local server, yes, you're doing a bunch of computation on your local server, but no one else on the internet has access to it. Twilio, for example, is not on your server, and so it doesn't have access to it. And so you need to have some way to expose your URL, your endpoint, to the rest of the world. And so in order to do that, we use another service known as NGROK. And over here, I ran the function earlier as well. It's NGROK HTTP, and you use the specific port that you're on. So we're on port, if I run node index.js, as you can see, I have a print statement earlier on, which prints out what port my friendly app is running on. So ours is 3001. You can change this. I defined this port over here in my application. You just need to make sure that the port you're running your backend and frontend on do not clash. Otherwise, things are going to get messy. So NGROK HTTP 3001. And now NGROK is exposing our local endpoint to everyone on the internet. So you can click Command, click, copy this, and then put this over here so that Twilio can now route our application to this URL. As you can see earlier, and even right now, I'm going to have my application endpoint /transcribe. And this is because in my code, I actually defined the transcribe endpoint to be the endpoint that handles all of the calls. It's not just the plain / endpoint. And so you need to make sure you have that in order to not have any bugs. So what that means is when we come over here, when we come to our index file, when we come to the transcribe endpoint, it'll run this asynchronous function. What this function is saying is we're going to create some Twilio ML response, which is kind of like Twilio's version of HTML, and it enables Twilio to speak and receive the text that you print out or it receives. And what we're saying over here is I'm actually storing a lot of session variables, and all this means is each time Twilio runs, the information might be lost if it's stored in variables. And so I'm using session in order to store values. So I'm hitting request.session.init, which to me just means, is our session initialized? So if it's not initialized, then that means the call has just started. And so we just want to simply say 911, what is your emergency? This value is just hard coded in, and it's used to initialize the rest of the conversation. And I chose a voice that I liked. And then again, over here, it's just on initialization of a call, I'm resetting all of these values to a new ID with a mathematical function I wrote out to receive an individual unique ID, and setting everything else to undefined and just basic default values. And otherwise, if it's not the first time this call is taking place, meaning this call has been going on for a while now, meaning that this transcribe endpoint hasn't been just called once, meaning the conversation should be continued, not just restarted and reset. So instead, we'll run this, which is like gathering information. And specifically, we're gathering information by running the action respond. So now, after routing to the transcribe endpoint, we now want to reroute to the respond endpoint. We can go down here and see what code is being run in the respond endpoint. Again, we're just creating some new basic Twilio response. The main gist of things is over here, where we start creating our AI response. We're awaiting generate AI response given our request. The request stores the previous spoken transcribed text that the user just said, and that's going to be sent to the generate AI response function. And this is another function that I wrote down here. I was just doing some basic console.logs to see the information coming through. And then I'm doing a couple if-else statements to see what step of the journey we're on in this conversation. If this individual we're conversating with has not given us our emergency yet, we're running this. And we're running a request to Open.AI to get the emergency out of this conversation. And if you check out my third video that I'll be posting in a little bit, you'll see that I talk a little bit regarding the differences between GPT and BERT. Specifically, this task we're completing right now, this is actually a BERT task. It's historically known to be a BERT task. It's a question answering question. And what we're telling the model to do is extract the emergency out of this given text. So when someone says first, like we saw earlier, the first prompt is 911, what's your emergency? And then the user tells them the emergency. And now we want the AI to extract the emergency from that. And although this is commonly a BERT task, I'm using GPT because I found with the right prompt engineering, it was actually giving me better results. And by prompt engineering, I mean this, the prompt that we're giving GPT. I know that GPT is a text generation model, but by prompt engineering it in this way, I'm actually able to get the information I want. So I told BERT, pretend you're a 911 dispatch officer, here's an emergency, and just extract the nature of the emergency in less than 5 keywords. And with that, I'm able to get some keywords that I want to display over here as the emergency. Here you can see like the emergency is being followed, car crash, being followed, car crash, car incident, and like all the different like shooting. They're all extracted by the model by OpenAI and the API because I completed the right prompt engineering. Now, I know it seems really obvious right now when you see like the way I prompt engineered it. It makes sense, the prompt that I gave it, but it actually took a lot of iteration when I was building this application to figure out what I need to tell the model, because later on, I continue with the same sort of thing, prompt engineering, depending on what stage of the journey we're on. I specifically hard code trying to get the name, the number, the location, the nature of the emergency. And then after that, OpenAI takes full charge and it does all of the prompt generation. It starts giving the individual advice and it starts asking more detailed questions. And this is all automated. And for that part, I had to do some very intricate prompt engineering. I needed to tell it, oh, you're an AI dispatch officer, give them advice or ask more information, extract more details, that sort of thing. And I was running into errors where my model was actually continuing the conversation for both the dispatcher's roles and the caller's roles because, as mentioned earlier, GPT is just a text generation model. It's trying to continue the response, see what would be written next. And it was really hard to stop it sometimes. In other situations, the GPT model, Text Davinci in our case in particular, was repeating itself. It would give me the same advice like twice, like in different parts of the conversation. And so I needed to explicitly tell him, like, don't repeat yourself sometimes. And so it was a lot of trial and error trying to understand the prompt engineering and how to optimize that. But in the end, we were able to get it to work. And I was even able to intricately kind of get OpenAI to tell me if an individual didn't provide the correct response. And if I detect that after asking the individual, hey, give me your name, if they're like so freaked out because they're in an emergency, they're like, just hurry up, just give me help, they don't give that information, I was able to check with the model again, did they give us the information? If they didn't give us the right information, return undefined. And then with undefined, we're able to prompt them again until they actually give us that information. It was, again, just a lot of a trial and error, trying to understand the scenario that we're being put in, trying to understand all the different situations that can occur, and then making sure we're addressing those accordingly. And that's the main gist of this. So we're just making API calls to OpenAI. We're using Twilio to speak the text and transcribe the text. In terms of getting your OpenAI key, you'll need to head to Open.AI and then create an account. Just go here, click on APIs, click login or sign up accordingly. If you need to sign up, just create an account. It's not too difficult. You should be able to click over here, view your API keys, and then just simply create a new secret key, and then you'll use that. So if I click on that, you'll just want to copy this and then put it in that env file that I showed you earlier. Now, another more complex topic we need to talk about is actually how this information is being later sent back to the front end, to that priority cards component that we had set up. The major issue is that typically in applications, you'll send an HTTP GET or POST request between your front end and your back end, your client and your server, in order to send and retrieve information. But the issue is that in our case, the front end never knows when to call the back end. It never knows when a call is taking place, when a call has ended, when information is ready to be returned. And so our front end can't send a message. Rather, our back end is where all the information is right now stored. Our back end is communicating with Twilio, and the back end knows when a call starts and ends. Since we can't establish a connection backwards, like our backend can't just push information to the front end like that, I needed to find a way around that. And so after a little bit of research, I decided to use Websockets, which is a way in which we can establish a connection between the front end and a back end by establishing a handshake. So at the start, if we go to the priority cards page, you can see over here, I'm using Socket.io and I'm setting up a web connection to our local host 3001 port. So that's the port that we set up over here. And now what we can do is set up a connection, which is kind of like a handshake, that's telling our application, create a connection between these two. And then we can come over here, and when we're ready to give information, we can start sending it by using, again, Socket.io, which I import somewhere over here. So I set up our Socket.io connection over here as well, saying that our origin is this, and now we can use the get and post methods through this. So basically what this WebSocket connection has done is established a connection between our client and our server. And now whenever our server has information it wants to give to the front end, we can do that accordingly, all in real time. Coming back here to the priority cards page, we're saying socket.onCall event. So whenever this is sent, information is sent, we're going to run this function. What we're doing is we're making a copy of the priority cards, so all of the emergencies that we already have, and we're destructuring it like this in order to get a copy of it. And then we're creating a new card. We're creating a new emergency, basically. And we're putting all of the information that has been sent over our server. So we're using our call dot, whether or not it's in progress, the name, the number, the emergency, the location, the ID, all that fun stuff. And that's being done over here. We're emitting the call progress event, and we're sending all of this information. Then we're checking if there's a duplicate. So there will be duplicates because we're sending this information and creating a new card each time. And we don't want there to be like 50 Rachel Green emergencies each time that she sends, like she says another phrase. And so I needed to search for duplicates and check if this is the first time that she called, this is the first statement she said, there won't be any duplicates, so we can just push it to our array. Otherwise, we just want to replace it because on the server side, we're just appending to the transcript, so we can just replace it completely. And then we're setting the priority cards to be the new cards that we have. And in React, we're using state. And what state is, it's a way to store variables, but when these variables updates, it's going to re-render our page so that all the information is re-rendered and shown to the dispatchers in order to make sure that everything's live, synchronous, and happening in real time. One feature that I mentioned earlier on that I wanted to include was the ability to detect duplicate emergencies that are coming into the system. For example, over here, if you look at Bruce Wayne and Tom Holland, is it? I think it's these two, Bruce Wayne and Bob Marley. You can see that both of them are having similar situations. Bob Marley sees a car accident and Bruce Wayne sees a car crash. And coincidentally, they're both on Airport Road. if these calls are coming in at the same time, you should be able to assume Bruce Wayne and Bob Marley are both reporting the same accident. Both of them, if you read their transcripts, they are slightly different, but both of them aren't in the accident themselves. Bob Marley's telling us there's a big accident on the road, and Bruce Wayne's telling us that he just saw a car accident on the road as well. And so it's slightly different, but it's also very similar. And a dispatcher would be able to really quickly kind of identify that these are the same emergency. They're both providing information regarding the same issue on the road. There's been a car crash. And so we don't want to send duplicate efforts to this situation and like waste resources or time. And it would be also very helpful if these two are grouped together in order to see that we have all this holistic view of the emergency coming in. And so I began building out a method to detect duplicates by using BERT, sending in the transcripts, and identifying similarity scores. And that's exactly why I have these priority card 2 and content 2 files, because it implements that feature. The reason why I didn't end up keeping this feature was because it was slowing down the system a little bit. And quite frankly, the system wasn't as good as I was hoping. A lot of the times it would detect two emergencies to be similar, even though they weren't the same emergency. If you think about it, if Bob Marley and Haley Ali see an emergency, these two might be more similar than an individual who's in a car crash, for example, and one reporting one, even if these two are happening at the same location, whereas these two are happening at different locations. So, of course, if two emergencies are happening in two completely different locations, they're not the same emergency. They both might be seeing car crashes, but they're at different places. And so we want to send dispatch efforts to both of them. Whereas if Bob Marley and Tom Holland are both referring to the same emergency, yet one is in the emergency, one is seeing the emergency, in that case, we don't want to send duplicate efforts. I did partially implement the system using a Hugging Face model. And if someone did want to pursue this model further, they could do so by using heuristics. The way I originally planned it out was to take the location, because the location is a very big indicator regarding whether or not it's the same emergency or not. So you could take the longitude, latitude value of the emergency, say that one emergency is here, and Tom tells us, oh, the emergency is on Hagerman Street. Whereas Bob tells us, hey, the emergency is on like near Toronto City Hall. By taking the longitude, latitude values, you would be able to see how similar the locations are by taking the change in the longitude, latitude values, and then adding this to the similarity scores received by the BERT model. And if we take a look at the code over here for priority card 2, we can see how that is being handled. Basically, instead of just taking the emergency and inputting it, detecting if there's a duplicate, and then changing it accordingly, we also check if the call is done, if the call is no longer in progress, and as long as we haven't already collected a similarity score, then we're running this function. And this function is running a request to an SBERT, which is a sentence BERT model stored on Hugging Face. You can take a look at the documentation for the specific model I used. But in order to make a request to this model, we need to send a query filled with these arguments. So a source sentence, which is our current emergencies transcript, and we want to compare it to a bunch of sentences. So this should be a list of sentences that we want to compare this transcript to. I'm mapping all over all of the other emergencies that are in the system. So if Bob Marley's currently calling in, it'll be compared to all of the other cards' transcripts by appending these into a list. Once we run this query, and the code for this query is written up here, this is again just taken from the documentation for the specific model. This is the arguments that we need to fill in. So once we run this query, we'll be having this data list populated with the similarity scores, which is what the SBERT model does. And what I'm doing over here is I'm taking the maximum of the similarity scores, because of course whatever the highest similarity is, that has the greatest chance of being the same emergency. And then we're getting the index of that max score in order to get the index of the emergency that this emergency is the closest in similarity to. By getting that kind of like parent emergency, we're able to store that, but I only want to store it as the same emergency if the maximum score, so the score of that similarity, is greater than 0.75. This value 0.75 was something that I found to work best when I was creating this code. I figured out that if the value is greater than 0.75, that means that they're very close in similarity and they're most likely the same emergency. But as I mentioned earlier, this is not always the case. You need to look at other arguments as well, like the location, in order to ensure that it is the same emergency. Because in my case, I was getting some emergencies detected as duplicates that weren't actually. And this has a simple fix using the heuristics, but I didn't end up implementing this because it was slowing the model down as well. But if this is a priority for you to implement such a feature, you can do so this way and just get the longitude, latitude values, multiply by this by some weight, and add it to the similarity score in order to get a final similarity score. And then all the rest of the code is exactly the same, no changes here. If you want to see how this version of the application looks, we just have to change two things. I actually have a content to and a priority to file, which is it compatible with this version of the application. And if we go over here and change this to content to, and then make sure that content to is using the priority to cards. Oh, and over here, I was showing how instead of mapping over priority cards, which can be confusing for someone who's new to JavaScript, it's literally the exact same thing as just writing priority cards over 5 times, kind of like a for loop. And it enables you to just, in less lines of codes, do this same exact thing. So writing out priority cards like this is the same as in this content page where we're mapping over them. So now that I changed both of those, I forgot to import content to over here. Now if we reload this page. Sorry, I just had a bug there. When I changed the priority card value over here, I forgot to name this import, change the file and the name of the export. And so I just fixed that quickly. And now you can see that this is how the application runs when I implemented that similarity score feature. Now, what our system did was it detected that Bob Marley and Bruce Wayne were reporting the same emergency. And so what a dispatcher would be able to do is click on Bob Marley, and then they can change whose emergency call they want to learn more about. So they can learn about Bob Marley's emergency or Bruce Wayne's, and then they both have sort of a little bit different information, but the system detected them as the same emergency. And that's why they're both displayed here together. Kind of shows you that there's 2 emergencies in this group, and then you can toggle between the 2. And all that code is written basically in the same way. I showed you the party card 2 and how that code's a little bit different. And the content also has one minor change. Instead of previously how our data was stored as objects within a list, I had this information being stored as a list within a list with objects. And I did this in order to show that this list has all of the emergencies that are representing the same emergency. And then that way you can keep pushing more emergencies to that list to represent more emergencies underneath it. Whereas if it's just an individual emergency, all these other ones are just one, it'll just be a list with one element. And that's how everything there is working. Okay, so that's it for all the code. Time for some fun stuff. Let's run some sample emergencies through the system to see how it responds. I'm just going to change this back to our original version. When I save the file, it's going to start recompiling. It's written in the terminal. Once that's done, our page should reload and the original emergencies should be back. I'm going to send calls to my Twilio number. If you're running this system on your own local server, you'll need to call a different number. But yeah, I'm going to call this number and then see how our system automates the incoming emergency calls. I'm going to pull up my notes here.
911. What is your emergency?
Help! I'm in a car crash.
Okay, stay calm. Can you tell me your location?
Yeah, I'm on Maple Street and George Road in Toronto.
Okay, can I get your full name?
Yeah, my name is James Smith.
And what's your phone number just in case we are disconnected?
559-735-8573.
Can you tell me what happened?
Yeah, I was just driving straight and all of a sudden another car was taking a left turn and just hit me.
What is your location?
I'm on Maple Street. We just pulled over to the side of the street, but both cars are really badly hurt.
Don't worry, help is on the way. I'm going to end the call to coordinate dispatch efforts, but you should hear back from 911 officers really soon.
And with that, James' call is now in the system. They can send dispatch efforts according to priority levels, and they can just open up the emergencies. The dispatchers can read through everything, assign it a particular priority, and then everything can be handled according to the resources available. Let's do another one.
911, what is your emergency?
Help! I'm being followed.
Okay, stay calm. Can you tell me your location?
Yeah, I'm at the Toronto Pearson Airport.
Okay, can I get your full name?
Yeah, my name is Emma Davis.
And what's your phone number just in case we are disconnected?
My number is 335-789-1459.
Emma, I want you to keep talking to me until the police arrive, okay? Do not hang up. I'm going to stay on the line with you. Please tell me what is happening.
Yeah, I'm really scared. I'm right now in the terminal area and this man just he just keeps following me.
I'm going to need more information. Can you give me a description of the man who is following you?
Yeah, he's wearing a black hat and a black hoodie, but I can't see his face too well.
Don't worry, help is on the way. I'm going to end the call to coordinate dispatch efforts, but you should hear back from 911 officers really soon.
And with that, Emma's call is into the system. We can read her transcript. We can begin scheduling some dispatch efforts, send the help that she needs, and all the information is readily available for the dispatchers over here. I know that there is a lot going on. We're using Twilio, we're using GPT, we're using Hugging Face, and there's a lot of other programs I had to work with as well in order to kind of get to this phase. I started off working with JavaScript and using JavaScript's built-in functions in order to handle the voice and the transcriptions. And then I slowly leveled up to Google Cloud and so on. I know that this code walkthrough in general, could have been confusing for those who are a little bit more new to React, a little bit new to Backend, or a little bit new to working with APIs, WebSockets, whatever. And even for me right now, explaining and going through the code, it was difficult because there is so much going on. And this was a project that took me a couple months to work on. But if anyone is deeply interested in this project and understanding how it works, definitely reach out to me. I can go into more depths into specific questions or features you want to speak about. But this was a general overview of all the different functionalities, all the different features that I used in order to get this application working. And I hope that you enjoyed this walkthrough. If you're more interested in learning about the AI and ML aspects of things, definitely check out my third video that will go deeper into transformers, the architecture, and how the AI systems work. I hope that you enjoyed this code walkthrough. I hope you were able to learn something. I hope that you were able to take away something, and I will see you in the next one.